Hello, good day. I'm Anagha Asok.
I'm Padma Piya. We are third year BTech students pursuing Electronics and Communication Engineering in Amrita Vishwavidyapeetham. Here, we demonstrate the project titled Virtual Mouse, implemented as a part of Texas Instrument Innovation Challenge India Analog Design Contest 2014.
It has been our long-term aspiration to develop a wireless system which helps the presenter to do all actions that mouse does on the desktop directly on the projector screen. It functions like a mouse arrow which is projected, and hence the name virtual mouse. Here, first of all, we demonstrate the hardware side of the project and later a real-time application of the same.
The system consists of three parts: ultrasonic transmitter, receiver and PC interfacing circuit. The ultrasonic pulses are transmitted and it is converted into 8-bit digital value using ADC module of MSP430F247. The intensity level is used to track the position of transmitter and the motion is shadowed by mouse pointer. This is done using Visual Basic and clicking action is facilitated by IR module.
Here is the transmitter side of the system. It has four parts: the power supply unit, the controller, the ultrasonic transmitter and the infrared transmitter. As you can see, the power for the unit is delivered using a power supply unit consisting of a transformer, a bridge rectifier, a filter circuit and 7805 voltage regulator. This is controlled using an MSP EXP430G2 emulation board. Pin 1.0 of the board is used as output to the ultrasonic module and pin 2.2 is used as output to the infrared module. The controller is coded to get 40 kHz ultrasonic pulses and continuous infrared pulses using Code Composer Studio. IC HCF40106BE is used to interact with the ultrasonic transmitter, and hence ultrasonic pulses of 40 kHz are emitted continuously. Similarly, infrared rays are also emitted through the LED coded using the emulation board and controlled by the switching action of BC547. Here is the receiver module of the system. It consists of mainly 5 parts: the power supply unit, the Bluetooth module, the controlling unit, the receiver circuit and the sensor board consisting of 4 ultrasonic transducers. The power supply unit of the system is same as that of the transmitter system. The sensor board is the main part of the reception module. It has 4 ultrasonic transducers which are individual receivers. They together cover a rectangular area. The transmitter is moved within these boundaries and each transducer receives signals from transmitter. The receiver are connected to the receiver circuit, each having 2 LM358N op-amp ICs used in inverting configuration to amplify and retain the received signal. These 4 circuits are the receiver circuits of the 4 receivers, and the output from the circuit are fed to ADC module of the controller MSP436F247. The ADC module converts these values to 8-bit digital values. It is displayed as corresponding decimal values in the computer. Here is the Bluetooth module used in the system. It is AUT-BM20 and it takes a digital output from the processor and sends it to the receiver counterpart in PC interfacing circuit. This is OPT101 photodiode. This IR receiver consists of a comparator circuit whose reference voltage is given to the inverting input terminal. The non-inverting terminal is connected to photodiode. When photodiode senses infrared rays, the receiver does not contact and the comparator output is logical high, which is identified to execute a double click. The coding is done in Visual Basic. Hence, when there is no infrared interrupt, the output is logical low, which is identified not to execute any clicking action. This is the PC interfacing part. It has 3 parts: the power supply unit, the Bluetooth module and the serial programming unit. The power supply unit is same as before. The Bluetooth receiver module is AUT-BM20 and it receives data transmitted by its counterpart in the receiver circuit. The data received is sent to MAX232 driver receiver, which is a serial programmer. MAX232 connects to a serial port which uses RS-232 standard protocol. Since the module functions using capacitive voltage generator, external charge pump capacitors are used to support internal voltage doublet inverters. Now we are going to switch on the system. As shown, the power supply to the transmitter side, the receiver side and the interfacing circuit is switched on. The ultrasonic transmitter uses MSP EXP430G2 to perform the control functions and transmit 40 kHz ultrasonic pulses. The receiver receives the signal. Then the analog signal is converted to digital, that is corresponding 8-bit binary values using ADC module of MSP430F247. From the processor, the output of ADC is fed to Bluetooth module. The values are sent to the interfacing circuit via AUT BM20, the Bluetooth module used. In the interfacing circuit, the receiver Bluetooth module receives these values and these are sent to the PC via serial communication. Now let's see the digital values from the receiver signal getting displayed in the hyperterminal. One can see 4 sets of values getting displayed in the hyperterminal corresponding to 4 transducers. For example, as on line 1, it is 206, 198, 201 and 95, the receiver signal value corresponding to the present position of transmitter. This is the Visual Basic application developed to process the values, compare it with the screen resolution, and facilitates the mouse arrow to shadow the transmitter. Infrared interrupts facilitates the clicking action. Now, as you see, the arrow reaches the start button when the infrared interrupt occurs menu pops. Now, here is a real-time application of our project during a presentation. So, hence the working of the project we designed and implemented. I strongly believe that if developed commercially, our project does find a very inevitable position in the digital market. Hope you all followed and liked what we presented. It's me, Anagha, Asok,
and Padma Piya.
signing off. Thank you.